Okay, so we're back for part 2 here. Sorry for cutting off in the middle there. I had a quick discussion I had to have with another colleague. Number 2, let's change each logarithmic expression into an exponential. So now let's go the other way. Let's go from the logarithm to the exponential. So the log base b of 7 is equal to 4. Now when we write an exponent, we need the base. In this case, the base is b. The exponent is this value. So b to the 4th is equal to 7. All right, the base here is a raised to the exponent is equal to w. And then this one would be 5 raised to the x is equal to 10. Now where we're going with this, there are going to be times where we want to write something as a logarithm because it will help us to solve something. There are times where we want to write it as an exponential. Okay, so for example, number 3 here, it says evaluate each expression. Now, when we see that word evaluate, it means come up with the value, so get the value. Usually that's going to be some number. So we want to get the value for each expression. The log base 2 of 8 is 2 raised to something. Okay, we don't know what this is equal to. 2 raised to something is going to give us 8. Now, we can try to find what is this exponent. So think 2 raised to what power is going to give you 8? Well, one of the rules that we're going to be using in equations, if you have an exponential equation, and let's say b raised to the u is equal to some base b raised to the v power. Now, if these are the same base, for them to be equal, then the exponents will have to be the same. So we would say then u is equal to v. Okay, so what I can do here, now you can do this in your head. 2 raised to something gives us 8. But the number 8 can actually be written in the same base. That's 2 raised to the 3rd power. And so in this case, what would this exponent have to be? Well, it has to be a 3. So the answer to this, the log base 2 of 8, is equal to 3. Now, a lot of times I'll just use the variable x here. So I would say x equals 3, or you can just say is equal to 3. The log base 5 of 25, we're thinking 5 raised to some exponent equals 25. Now 25 can be written as 5 squared. So 5 raised to something equals 5 to the 2nd. Well, that something has to be 2. Now the log base 3 of 1/9, 3 raised to something equals 1 over 9. Now when we look at that, 1 over 9 is the same as 1 over 3 squared, but we can also write that as 3 raised to the negative 2. We can use a negative exponent for that. So we've got 3 raised to something equals 3 raised to the negative 2, so that something is equal to negative 2. So we can evaluate these logarithmic expressions by changing them to exponential and then just working it out, just thinking our way through the problem here. Now the last 2 here, d and e, in part d we have the log base 5 of 5. 5 raised to something equals 5. Now the number 5, I can just write that as 5 to the 1st. So what's the something? The something is 1. And then this would be 7 raised to something equals 1. Now this one, we need to understand our rules of exponents. Anything raised to the 0 power is equal to 1. So whether that's 125 raised to the 0, if you type that on the calculator, you get 1. So that value there, when we evaluate that, that's going to be 0. Okay, so this gives us a couple of rules here. Now if we flip this onto the second page or onto the back, basic logarithmic properties that we've got, there are some shortcuts for when we're looking at this. The log base b of b. if these numbers are the same, remember, we're thinking b raised to an exponent, b raised to something, has to equal this, which is b to the 1. So this is automatically, this value has to be 1. The log base b of b is always going to be 1. So if I gave you an example, if I said the log base 12 of 12, you automatically can just say that's 1. That's your answer. The log base b of 1, so b raised to something equals 1, well, that has to be 0. Anything raised to the 0 power gives us 1. Now let's say we have the log base b of b raised to the x power. Now this is a case where I'll show you if we change that to exponential, so we take the base raised to something equals this expression, which is b raised to the x, we have the same base, therefore these have to be equal, so this is equal to x. So if you see the log base 17 of 17 raised to the 9th, your answer has to be 9 for that. And then the last one here, this is written as an exponential. So this time, let's change this to a logarithm. So it's the log base b of something is equal to the exponent, which is the log base b of x. So now we're going to write this. This is exponential. Change that to a log. So the log base b of this gives us the exponent. Now, if we have the same bases again, then that means that this piece and this piece have to be equal. So this is a confusing way to say that your answer is just x. So if I say 8 raised to the log base 8 of 5, it's going to be equal to 5. Okay, so evaluate each of the following logarithms. The log base 3 of 3 raised to the 8th, well, that would be this property right here, and the answer is just the exponent 8. The log base 3 of 3, now that's like 3 to the 1st. That's this property right here. Our answer is 1. E raised to the log base e of 2, that would be this property here, and the answer is just this value, so this is 2. And then the log base x of 1, that would be this one right here, that is equal to 0. So if you know these properties, you don't need to convert from one form to another. You can just go ahead and say the answer. And again, where this is important is if we start solving these kinds of equations, we're going to be using these properties to help us. And that's the end of part 2.